Number 3 for the practice exam, the lamb's quarter is a common weed that interferes with the growth of corn. And agriculture research planted corn at the same rate in 16 small plots of ground, then weeded the plots by hand to allow a fixed number of lamb's quarter plants to grow in each meter of corn row. No other weeds were allowed to grow. A scatter plot is given below with a least squared regression of the 16 collected data. In order to investigate if lamb's quarter plants reduced corn yield, the following computer software Minitab output is provided based on the researcher's data and a prediction value using 6 weeds per meter. Okay, so this is the scatter plot. This is the regression line. And this is the Minitab output. Or notice in the scatter plot, the weeds per meter is the explanatory, and the response is the corn yield. Some key things that you need to notice and distinguish from this output are the p-values. This is the p-value that we're using, 0.038. This is the p-value if we're testing that rho is equal to 0 and the alternative is that rho not equal to 0. This upper p-value, this is the p-value if we're testing if the y-intercept is equal to 0 and the alternative not equal to 0. So again, we're using the bottom one. This is the p-value that we're using with the test that we do. The other things that you need to recognize is that this right here, negative 1.0987, this is my slope. 166.483, that is my y-intercept. And so if I'm writing the equation of the line, it's 166 plus or minus 1.10x, and x is, again, weeds. The other numbers, standard deviation, 7.977, and r-square, 20.9. R-squared is calculated by taking r and squaring it. So if we wanted to calculate what r is, we would go square root of 20.9. Oh, it's already done. Square root is 0.45, which is 45.7. So to answer the question, it says, which of the following statements about the regression line is true? So let me go over D and explain why that's true and talk about why A, B, and C aren't true. So letter D says the value of r squared is relatively small. The regression is not useful for precise prediction. Okay, so take a look at how small r squared is. It's 20.9%. Remember that the definition of r squared is r squared is how confident you feel about this regression line in predicting for y. So if you plug in 8 and you predict it based on the line of what y could be, 20.9 is how confident you are that this line is really good at predicting. So it's a really small confidence, really small percentage of how confident you should be about this line. So that's why it's small and it's not really that useful to predict because it's not that precise. Well, if you look at C, it says the value of r squared is relatively small, which is true, but the regression line is useful for precise prediction. So that's that's just not true. That's the opposite of what we're saying for D. And then A and B you can disregard because they're saying that r squared is a relatively large, which isn't true. So that's why the answer is D.